Spencer, the only direction you should be looking is forward. Why did you switch seats with Diana?
She was sitting there, and he was somewhere else. I was sitting
Who moved seats first? When you came in, was that seat open or was Diana in it? So then, Diana, why did you move your seat? So do you want to move your seat? Okay, good. You could go sit behind Rachel. All right. Now, Ishi, if you would kill the lights, please. Write the number which is equivalent to 2 to the 7 over 2 to the 4th. When you see that, 2 to the 7 over 2 to the 4th, what pops into your head? Yeah, well, right, because of the over. So what do you do with the exponents? You do not multiply. Well, you could do that, but there's a shortcut, a rule that we do with exponents. Like if I said I had x to the 5th over x to the 3rd, what would that equal? No, x to the 5th over x to the 3rd. Guys, I know you know this. Come on, what do you, not 8, no. X to the 2nd. Because x to the 5th is this, x to the 3rd is this, die, so you end up taking them away. What operation is take away? Subtraction. So 5 minus 3 is 2. Now, I find it kind of odd because just about every person in the room got this right. Maybe, did you guys like use your calculators?
Yes.
Oh, yeah, we don't want to, no, we're looking to do it a little bit shorter than that because a question like this would be on part 1 of your state test. Or your, well, I think on the final you're allowed to use a calculator. But on the state test, it would be very much on the part 1 for all of you. Oh, by the way, how many people here have not opted out of the state test? Have not opted out. 1, 2, 3, 4, 5, 6. Okay. So what happens is you wouldn't be expected to do this without a calculator. You would not have a calculator on this part of the test. And what we would look for you to know on this is that you subtract exponents. You remember how, like, if we did a scientific notation question, we'd say 8 times 10 to the 15th over 2 times 10 to the 7. You would do 8 divided by 2 is 4, and then 15 minus 7 is times 10 to the 8. You know how we would do that? Hey, do you understand, right, that we would subtract exponents there? Well, likewise, we subtract them here, and I get 2 to the 3rd. So which one of these equals 2 to the 3rd? D. 8 is correct. So be careful with that calculator. Now on number 2, I actually made a mistake, and the choices, none of them are right. So no matter what, I gave everybody credit for it. Okay? Well, look, first I have to multiply 900.5 times 2. And then that would give me 0, 1, 0, 18. Decimal point there. But now I need to convert to scientific notation, 1, 2, 3 places. So I get 1.801 times 10 to the 3rd times 2 times 10 to the 8th. And that would work out to be 3.602 times 10 to the 11th. And we didn't have that for any of the choices, so I just gave everybody credit for that. As far as draw a graph that's not a function, it has to fail the vertical line test. And this is the table, x, y, and then I'll fill that in just a minute. So if I draw this graph, I saw one kid drew a Z. I thought that was a pretty good graph. Okay? So if you draw a Z and then I do my vertical line test, won't I hit it at least one time? Any graph where it hits at least once on a vertical line is going to be not a function. It's not going to be a function, okay? If it touches only once, it is a function. And notice, keyword, not. Now, as far as the table goes, and making something not a function, you need to repeat an x value. So I saw some people do this. 2, 0, 1, 2, 3, 4. Some people did 2, 2, 0, 0, 4, 4. as long as they repeat. Now, I don't care what the y's say. Let's just say, for argument's sake, that the y says 0, -3, 1 would be, I don't know, -1, 2 would be 4, 3 would be 6, and 4 would be 8. If I graph that, 2, 0 is here, 0, -3 is here, 1, -1 is here, 2, 4 is here, and then 3, 6, and 4, 8. Can you see that if I draw a vertical line, it's going to touch twice, here and here? So you can either plot the points and see where it touches twice, or it's easier to realize that as soon as an x value repeats with different y answers, you have not a function. Okay? Questions? Now, next one. Write a function rule for the table. And I saw a lot of good things going on here too. We know the function rule in general is y equals mx plus b. A couple of people didn't even put that, but the overwhelming number of people did put it. What are the y's going up by? 6. What are the x's going up by? 2. So what is the slope, which is change in y over change in x? What would that be? 6 over 2, which is 3. So I know I have y equals 3x. How do I find b? What's it always pair up with, guys? 0. So I'm going to put plus 11 because the 0 pairs up with 11. And then it says, is the function linear, quadratic, or neither? Listen to me. The thing that defines a linear function is when it goes up by a constant amount. See how it's always going up by 6's and 2's? When both sides are going up by a constant amount, that means it's linear. So the answer is linear. If it wasn't linear, I couldn't have used y equals mx plus b. Okay, any questions? Preguntas? Okay. I thought that was a pretty challenging quiz, yet you guys clearly did a good job on it. Lots of 84s. I'd say there were 3 or 4 hundreds. Raise your hand if you got a 100 or an 84. 3, 4, 7, 8, 9. We got 8 or 9, maybe 10 kids. That's more than half the class. So that's a really good thing. Now, what I would strongly suggest that you do is tonight, before you begin your homework, just take a few minutes to look this over. All right, we told you yesterday, don't bother doing this one. But here we want to know which choice has the greatest rate of change. And like yesterday, I need to put some points up here. So I'm going to do that now. Okay, so figure out the rate of change for A and then tell me which one has the greatest rate of change. Okay, Chris, what's the rate of change for A? What is it?
Y.
I just want the rate of change, I don't want the whole
1
function.
over 2.
Good. What's the rate of change for B?
5 over 2.
Okay, I was kind of hoping for somebody else. I know you know, I wanted somebody who, not yet. Angela, what do we got for C? Well, what are we going up by here?
3 over 1, sorry.
We're going up by 3, and then over here, we're going up by 1. So what's the biggest number? Is it a half, 5 over 2, or 3 over 1? 3 over 1. Remember we talked yesterday, for 5 over 2, you could divide to see what it really equals. It's 2.5. So what's bigger, 2.5 or 3? 3, definitely. Okay, so C has the greatest average rate of change. Last but not least, talking dilations. What operation do you use with a dilation? Multiply. So if I'm going to dilate this by a factor of -4, what do I have to multiply by? So what's 3 times -4?
12.
-12. And what's -4 times -4?
16.
16. Good. So there's my new point. -12, 16. Any questions? All right. So that pretty much is all review stuff. There's nothing new for any of that. We reviewed dilations. The other thing I want to just very quickly remind you about with dilations The big thing about them to understand is they change size. If I start with the blue triangle, everybody looking here? Caitlin? If I start with the blue triangle, and it becomes the green triangle, see how that size is changing? That must be a dilation. By the way, I could have started with the green one and become the blue one. That's also a dilation. Dilations can get smaller, okay? All right, so that's pretty much everything that we've talked about lately and what's gone on and so on and so forth. And we will continue to practice that every single day. Now, let's start talking about, well, we actually started yesterday talking about transformation geometry, and let's keep working on it. Some transformation geometry is based on the idea of symmetry. There's the word. Everybody say the word, symmetry. Write the word, write it out on your paper, symmetry. S-Y-M-M-E-T-R-Y. Just write that word, symmetry. Come on, Chris, let's go. Write the word. It helps you remember. That's why I'm asking you to do it. I'm not doing this because I want to waste your time. If I was a kid sitting in class, I would say to myself, oh my God, you gotta be kidding me. But the truth is that if you speak it, write it, read it, and use it in a sentence, say it out loud, you're going to learn the word much better than if you just listen to me say it. So symmetry means the same on both sides. Turn to a person sitting near you, tell them symmetry means the same on both sides. Same on both sides. Very good. Okay, so I have a whole bunch of characters here from different languages, mostly English, and I want to show you the symmetry. Take a look here. See how it's the same on both sides of that red line? We would call that vertical line symmetry. Vertical, why? Because what direction does that line go in? It's vertical. Up and down means vertical. Does anybody ever get confused between horizontal and vertical? That happened to me a lot when I was young too. So here's what you remember. Remember, you get a girlfriend or a boyfriend, depending on what is appropriate. You go to the beach. It's just you, your significant other, and your little puppy dog. And you're walking down the beach, and the sun sets on the horizon. Look at my arm. The horizon. This is horizontal. Okay? So, well, that's how you could tell which way is horizontal. So, this clearly is vertical line symmetry. Because if I could somehow fold the Eno board and take it and just kind of fold it over that red line, can you see that the left-hand half of this character would land on the right-hand half? That's what says it's symmetry. If that wouldn't happen, it wouldn't be there. Now, what about this guy? Does this have vertical line symmetry? No. Does it have horizontal line symmetry? No. So therefore, we would say that this one has no symmetry. Okay? I would like you to go through all of the next letters and on your paper, put a check mark next to all of the letters that have vertical line symmetry. All of the letters that have vertical line symmetry. What does symmetry mean again? Hey, that's fakes. What does symmetry mean again? All right, Chris has it, but I want the whole class to have it. What does symmetry mean? Same on both sides. Very good. Okay. Now, what about A? Does A have vertical line symmetry? Yes. Yeah, go right down the middle there. What about T? Yes. Yes. What about D? No. E? No. H? Y? No. K? B? Now, I want you to circle on your paper all of the ones that have horizontal line symmetry. Think of you and your significant other on the beach with a puppy. Well, it can be your dream girl, Ariana Grande or whoever. Not yet. We're almost done. All right. Does A have horizontal?
No.
No. Does T?
No.
Does D?
Yes.
E?
Yes.
H?
Yes.
Y?
No.
P?
No.
No.
Yo, I said yo.
You said yes.
I said yo.
No.
K?
She said no.
B? All right. Now, another place we can find symmetry is on a graph. So, let's do a little work here. Graph triangle A, B, C. Plot those points and put the letters A, B, and C next to the points. If you're a little fuzzy on where coordinates go, ask the person sitting around you. Okay, does everybody get ABC looking like that?
Yup, we did.
Right, we're good? All right. So let's look at what part A says. It says draw the triangle, label the points. Done. Next it says reflect it over the x-axis. And call this triangle A prime, B prime, C prime. Now, to reflect it over the x-axis, I can do this in one of two ways. One of two of the best ways. Check this out. Watch me. Being Superman, I can fold this Eno board in half and actually return it to a fully working condition. Not.
You what?
But your paper could do that. You could fold your paper over, see where it lands, and make dots. But I got a way better way than that.
Bruh.
I got a way better way.
Bruh.
I'm just saying you could do it. I'm not saying I would do it.
I'm gonna do
Big difference between coulda, woulda, and shoulda. Check it out. Ready? I'm going to do, every time I see this word reflect, everybody on your paper circle that word reflect. And then draw a little arrow to some open space and write the words count and repeat. Draw a little arrow to some open space, maybe like right up over here, and write count and repeat. And what you're going to do, this is very, very easy. Check it out. Watch. I'm going to count the distance to the x-axis, because that's where they said to go, and then repeat it. Ready? Watch me. Don't look down. Watch. Baga! 1, 2. 1, 2. I counted and I repeated. Now try that with B.
What? 1, 2.
See, I told you to watch. 1, 2. 1, 2. Count and repeat. Count and repeat. Do it. Do it for B.
1, 2, 1, 2, 1, 2.
Ready? 1, 2, 3, 4, 5. Now what do I do? 1, 2, 3, 4, 5. So this is going to be A prime. This will be B prime. Now what do I do?
Do C prime.
Take C. And what do I do? 3 words. Count and repeat. Ready? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6.
I did.
And there, now doesn't it look like you could fold it on the x-axis and they would land on top of each other?
No.
Liar, liar. You're telling the truth, he's lying.
Mine looks like a square.
Okay, now, hey, stop. It says write the new coordinates. What's the new coordinates of A prime? No, positive 5, negative 2. What about B prime? Positive 7, negative 5. And what about C prime? So, in general, what happened to every point? The x stayed the same and the y got negated. Okay, now what I want you to do, last thing for the day, ready? Take the original triangle on your paper, reflect it over the y-axis. Practice, count, and repeat one more time. Reflect it over the y-axis.
1, 2, 3, 4, 5.
Count and repeat. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. A double prime. 1, 1. C double prime. 1, 2, 3, 4, 5, 6, 7. 7. D double prime. There is my graph. Hasta la vista. Vaya con Dios. Toodaloo. Ta-ta. Arrivederci. Smile a lot. Same lesson tomorrow, don't forget.
Now, Thomas, do me a favor.
With the numbers changed, make sure we get it down pat. Karusharus, Kadafis, Shalom, Sayonara. Hasta la bye-bye, baby.